All right, this is Algebra 2, 3-76. How do we simplify these rational expressions? And remember, rational just means a ratio or a fraction. And although it's really, really tempting to see x squared and cancel, 9 and 9 and somehow cancel, we can't do that because these are not factored. We must factor first, okay? So the top, you can use box and diamond. And when you factor the top using box and diamond, you're going to get x plus 3 times x plus 3. Okay, that's what's going to happen on the top. On the bottom, you certainly can use box and diamond with a 0x in the middle, or we need to talk about difference of two squares. Some teachers call it dots. It's the difference. Okay, remember difference means to subtract of two, let me do this, squares. Two perfect squares. So as you can see here, we have two numbers, 1, 2. It's definitely a difference. It's minus, not plus. And both of these parts can be written as something squared. Okay? X squared is x squared. 3 squared is 9. So if I can rewrite these as the difference of two squares, then I can follow the pattern of x minus 3 and x plus 3. And this is just a shortcut called difference of two squares anytime you have a subtraction, two terms that can both be written as two perfect squares. Okay, so again, just a short way to factor. Now that I have both the numerator and the denominator factored, anything that makes a giant 1, like x plus 3 and x plus 3, right? Giant 1, okay, can get canceled out. And so what's remaining as my final simplified answer is x plus 3 over x minus 3. And I forgot that before I cancel anything out, I need to look for restrictions. Remember, restrictions happen when the denominator is equal to 0. In math, we cannot divide by 0. So any number that we would plug in for x that would make the entire denominator 0 is a restriction. Okay, so I'm going to write restriction. Actually, I'm going to write restrictions. After we factored, but before we canceled, we had an x minus 3 and an x plus 3. So x is not allowed to be a positive 3, because if I plug positive 3 in here, 3 minus 3 is 0. 0 times anything is 0. Not allowed. Also, for this one that got canceled out, and yes, we do need to pay attention to it, x cannot equal negative 3. Okay, so my simplified answer is x plus 3 divided by x minus 3. I cannot simplify this any further. And x is not allowed to equal 3 or negative 3. Those are my restrictions. Okay, part B, same concept here. Okay, I have this big fraction. I need to simplify. First thing I have to do is I have to factor the top and the bottom. Okay, let's see, when I factor the top, I'm going to use a box. I get 2x squared. I get negative 10. I get negative 20. X squared. On the bottom, I get negative 1x. Okay, so 4 and 5 are 1 away from each other. But one of them has to be negative, and because the sum is negative, the bigger one's negative. Okay, 4x, negative 5x. If you can't do that as fast as I can, no big deal. I've been doing this for a really, really long time. Don't worry about it if you can't do it that fast. Okay. Now when I factor here, up and down, 2x goes into both of those. 2x times x makes 2x squared. X times negative 5 gives me negative 5x, and 2x times 2 gives me 4x. So when I factor, excuse me, and don't mind Christmas Chronicles in the background, I get x plus 2, and I get 2x minus 5. That's my numerator factored out. Now the denominator, the elves are taking down the bad guys right now. All right, so for the denominator, I'm going to use box and diamond again. And it should be a little bit of a clue. If anything's going to simplify or cancel out, it's going to have to be one of these two factors. So let's see what happens. I have a 3x squared. I have a 2. I multiply those together and I get 6x squared. What's remaining is 7x on the bottom. Okay? If I'm trying to make something add that's bigger than the multiplication, usually it's as the big factors as big as you can get. So 1x and 6x. Multiply to make 6, adds to make 7. So here's 1x, here's 6x. Across the bottom, 3x is common. 3x times x is 3x squared. X times 1 gives me x, and 3x times 2 gives me 6x. So my two factors, x plus 2, from the bottom, 3x plus 1, those are my two factors. Now this time I'm not going to forget. I need to pay attention to the restrictions before I make any giant ones. So again, restrictions happen when the denominator is equal to 0. Okay, well what happens here? X cannot equal negative 2. Because if I plug negative 2 in for x, negative 2 plus 2 is 0, and 0 times anything is 0, and I'm not allowed to divide by 0. Okay? The other one, how do I find what the problem is here? I would set the denominator equal to 0, or really not equal to 0, and then solve. So 3x cannot equal negative 1. I'm just subtracting 1. And then dividing both sides by 3, x cannot equal negative 1/3. Okay? So two restrictions here. Let's take a look. I've got a giant 1 in the x plus 2 over x plus 2. So those can cancel out to simplify. And what's remaining, okay, my simplified answer is 2x minus 5 over 3x plus 1. So here's my solution with two restrictions. All right, part C looks super crazy. Oh my gosh, do we have to factor this? And the answer is no, because the top and the bottom are exactly the same. It doesn't matter what this is, okay? Anything, stuff, divided by the exact same stuff is always equal to 1, okay? It's exactly the same on the top and the bottom. 2 million divided by 2 million is 1. Any kind of number you have divided by itself is equal to 1. So that one was actually easy. Part D might look strange, but actually this one's pretty easy too. There are two terms, but they're not a difference. Neither one of those is a difference of two squares, so I can't use that difference of two squares shortcut. On top though, I can see that both terms have an x in it. Okay? So it's x times something. X, like if I were to distribute, how do I get x squared? X times x. If I were to distribute, x times what gives me 4x? That's a positive 4. Okay, so this is how we factor out. It's called factoring out a greatest common factor. Okay, what do they have in common? An x. If it's kind of like undistributing. What would I do if I distributed to get to that? The bottom, 2x plus 8, is the same concept. Okay, there's two terms, but it's not a difference, so I can't use that shortcut, but they both have a 2 in common. 2 goes evenly into both terms. So 2 times what gives me 2x? 2 times what gives me 8? And hopefully it was a little bit of a hint that something probably was going to cancel out. Not always, but probably. Okay, again, whoops. Before I do any canceling with giant ones, I need to check for restrictions. Okay, there's no way for 2 to equal 0. No way in the world. 2 cannot equal 0, so I don't even have to worry about that. But the only thing here that x cannot equal is negative 4. I don't have to worry about the top. The numerator is allowed to be 0. I can take $0 and divide it among everybody, and everybody gets $0. But I can't take a number of markers and somehow put them into 0 piles. I have to put them into some number of piles. Okay? Again, x plus 4, giant 1, which means they cancel out. And what's remaining here is x over 2.